Hello students, in today's video we're going to work on derivatives of exponential and logarithmic functions. So let's get started. So it'd be a good place for you to pause your screen and try this problem on your own. Hopefully you've paused the screen and you're just coming back right now to check your answer. Now remember, using our tables and using our derivative rules that I had you write down in your notebook, we're trying to find the derivative of sine inverse of 1 minus t. Now remember, the general rule is 1 divided by the square root of 1 minus u squared du dx. The important part to not forget is du dx. That means we need to find the derivative of the u portion in here. Now looking at the problem, we have u equals 1 minus t, and du is going to be equal to negative 1. Now applying the formula that we have, we know that 1 divided by, or sine inverse, derivative of that is 1 divided by the square root of 1 minus u squared. And our u is 1 minus t. And so this is what we should have to start, times our du dx. And our du dx in this particular case is negative 1. So we're going to multiply by negative 1 to the entire thing. Now we're going to get negative 1 times the square root of 1 minus, and this time I'm going to expand. This becomes 1 minus 2t plus t squared. And so our final answer should read negative 1 divided by the square root of 2t minus t squared. And that's it. So again, we just applied the general formula for this. So again, we're going over the derivative of logarithms and exponential functions. So let's go over a couple rules. When we find the derivative of e to the x or e to the u in this particular case, very, very simple derivative. The derivative of any exponential with a base e is the same e to the u multiplied by the derivative of that exponent, so du dx. So let's look at a problem that's a little spicier than the common e to the x problem. So in this particular case, you'll notice that we have the product rule. So remember, that's the derivative of the first times the second. So the derivative, so times the second is e to the 1 minus 2x plus the derivative of the second. Derivative of the second is negative 2, because if we take a look at 1 minus 2x and take that derivative, it's negative 2. E to the 1 minus 2x times the first. So the first is 3x to the fifth. And that's our final answer. Remember, they asked us to find the derivative, not to find the derivative and simplify it. So we're going to leave it at that. Looking at the next problem, again, another exponential, but we're just doing the quotient rule. So that's low d high, so the derivative of the high is cosine of x squared times 2x, because it's the chain rule inside. So derivative, or low d high minus high d low all over low squared. So low squared would be e to the 2x to the second power. And when we simplify that just a little bit, this becomes e to the 4x. So moving on, we have another rule. This time we have the derivative of a to the x. Now this is an exponential just like e to the x, but because the base in this particular case is not e, it could just be a different number, then the following formula is what we would use. So the derivative of a to the u is equal to a to the u times ln a times du dx. So let's look at a problem. So here, at what point is the slope 3x plus 5x equal to 10? So notice they're asking us for the slope in this particular case. So we're going to start with finding out what y prime is. Now y prime, using the formula, becomes 3 to the x times ln 3 times du dx. Now the derivative of ru, or the ru in this case is x, so the derivative of that is 1, plus 5 because derivative of 5x is just 5. Now, we want to figure out when the slope is 10, so we're going to go ahead and substitute that 10 in there for the slope, times 3 to the x, ln 3, plus 5. We're now going to subtract 5 to both sides, and we're going to get 5 equals 3 to the x, ln 3. We're going to go ahead and divide ln 3 to both sides. We're left with 3 to the x equals 5 divided by ln 3. Now we're going to natural log both sides because that's the opposite of our exponent, or that's the inverse for our exponential, and we're left with ln 3 to the x equals ln of 5 divided by ln 3. We're left with x ln 3 equals ln of 5 divided by ln 3. We're going to divide this ln 3 to both sides. We are finally left with x equals ln of 5 divided by ln of 3, all divided by ln of 3. Gives us a final answer of 1.38 for our x value. Now they asked us for at what point. So far we've only given them half of the ordered pair that we need. So we're now going to take this and plug it back into the original. Okay, because now we have the slope. And so when we plug this into the original, we are going to get, again, we're going to take the x value and substitute it into the original. And using my calculator, we're going to have the following points: 1.38, 1145. So let's try another quick problem. We're going to do sine inverse of e to the x. Remember, general formula for sine inverse is 1 divided by square root of 1 minus u squared times du dx. And so we're going to do that here. This is going to give us 1 divided by 1 divided by the square root of 1 minus e to the x squared. So that's going to be 2x, because if we're going to raise that power, times du dx. So the derivative of e to the x is just e to the x. So our final answer is going to be e to the x power divided by square root of 1 minus e to the 2x. And so that's our derivative. So let's look at another problem. This is the natural log. So the derivative of natural log, or of ln u, is 1 divided by u du dx. So again, for natural log, we do 1 divided by u and multiply it by the derivative of the u. So find the equation of a line that is tangent to the graph of y equals ln x and passes through the origin. So we have to read this one carefully because it says write an equation of a line that is tangent to the graph of y equals ln x and passes through the origin. So whatever it is, this is going to be a line that's tangent and passes through the origin, not crosses through the origin, because that would be a much easier problem. Because what's happening here is we have two things that we have to consider now. We know that there is some point that when we substitute in the value a, into the original equation, we're going to get ln of a. So I hope this part makes sense. We're just picking some arbitrary number a. When we substitute it into the original equation ln x, we get ln a. So that's one of the rules that we know. The second thing is that it's going to cross through the origin, which we already mentioned that, and that was a given. But the second thing we also know is that we are going to have the slope be equal to 1 divided by a. Because the derivative of ln x is 1 divided by x, and because we don't know what the point a is, we're just going to say it's 1 divided by a, and that's the slope of the tangent. So using our original slope formula, we know that we have ln of a minus ln of 0, because it crosses through the origin, divided by a minus 0, which means our slope is just ln of a divided by a, which is also supposed to be the same thing as 1 divided by a. Using our facts 1 and 2 that I wrote on the left-hand side. Now if we cross multiply here, we could find out that ln of a is equal to 1. And if we raise everything to the exponential power, we get e to the ln of a equals e to the first power. And we find out that a is equal to e to the first, or just e. Now notice what we did here. We raised everything to an exponential because e and natural log, or ln, cancel each other out. They're inverses of one another. And that's why we did it, so we can isolate the a. So now we know what a is. And now we're going to take it and put it back into our equation. So we have one minus ln of a. Actually, let's start with point slope formula. Y minus y sub 1 equals m times x minus x sub 1 equal to 1 minus ln of a equals 1 divided by e times x minus e. And I'm going to go ahead and replace this a already just to save us some time. We know that ln and e cancel each other out, so really that just leaves us with 1 minus, or y minus 1 equals 1 divided by e times x minus 1, because the e's cancel out. We're going to add 1 to both sides because I want to isolate the y. We get 1 divided by e to the x power. Moving forward, let's take a look at the next problem, or rule rather. So in this particular case, we're looking at the derivative of a logarithm. Again, please put this in your notebook or in your sheet for log rules. Now this one is saying log base a of u is equal to 1 divided by u ln a du dx. So I know this is going to take some time for you to get used to, which is why I'm asking you to reference your sheet all the time, because this way it'll slowly become a habit that you'll just memorize. So let's go ahead and try a problem now. We have log base 5 of the square root of x, or for the square root of x. Now using the rules that I just gave you, this is going to give us 1 divided by square root of x ln 5. Here's the part that might be a little tricky. So now remember, we're supposed to find the derivative of u. And u in this particular case is equal to x to the 1/2 power. That means du is equal to 1/2 x to the negative 1/2 power. So if this is what our derivative is, we're going to multiply that to what we have here. So remember, it's 1 divided by u, and the u in this case is square root of u, times ln of a, the base, which is 5, times the derivative of du dx, and that in this particular case is 1/2 x to the negative 1/2 power. So I'm just going to do one extra step to this, and that's going to be to change this to read 1 divided by 2 x, well, square root x times square root x times ln 5. You'll notice that we have 2 square root x's here because one was up here, or rather down here on the denominator, and this negative exponent means that we were supposed to bring it down to the denominator here. And again, we could simplify this as 1 divided by 2x ln 5. Now, please keep in mind, we could have just stopped here at this particular spot, right up here, but I just wanted to make sure we knew that we could go further if we wanted to. Again, this would have been just fine if they said find y prime. So the next thing I would like for us to talk about really quick is logarithmic differentiation. Now, sometimes it's going to be really difficult, but when we use logarithmic differentiation, it's used when the variable is in both the base and the exponent. So when that happens, we take the natural log of both sides and then use implicit differentiation. So we'll show you in this particular case. Now, we're supposed to find the derivative of x to the x power. So what we're going to do is we're going to follow the directions that I just gave you. We're going to natural log both sides, so ln y equals ln x to the x power. Now, because we have that, we can use some of our old rules and write this down as x ln x, because we can move the exponent down. Now we're going to take the derivative. So the derivative of ln y is 1 divided by y dy dx. Remember, when we take the derivative of any y, we add the dy dx there. Equals, notice we have the product rule here now. So derivative of the first, so derivative of x is 1, times the second, plus derivative of the second, times the first. So we're left with 1 divided by y dy dx equals ln x plus 1. Again, we want to isolate the dy dx, so we're going to multiply by y to both sides. That's going to leave us with dy dx equals y times ln x plus 1. And if you remember from our very first step, y is equal to x to the x. So that's x to the x power times ln x plus 1 as our final answer. So, quick tip for you. If we want to check our answers, another way to check our answers is to, 1, graph it on our calculator. Y sub 1, you'd probably want to put down as your own answer, your answer to, say, the derivative of whatever function. And then in y2, you're going to use the math and deriv, which is going to find you the derivative. You're going to enter in your original function and then fill it in with x comma x. So what you can do from here is you can look at the graphs and make sure they're the same. Not the biggest fan of that because they could look close but not be the same. So I'm going to have you press second and graph so you can take a look at your table and make sure that the values are the same. So let's take a look at another problem. For this one, I want you to now find the derivative of cosine inverse of x minus 2y equal to e to the 2x plus y. Remember, our rule for cosine is that it becomes negative 1 divided by the square root of 1 minus u squared times du. So just to clarify, u is equal to x minus 2y, du is equal to 1 minus 2 dy dx. So we're going to go ahead and start with this now. This becomes negative 1 divided by the square root of 1 minus x minus 2y quantity squared times du. Remember, the derivative of u is 1 minus 2 dy dx equal to the derivative of e to the 2x plus y. Remember, we bring that down, the u, we bring down the 2x plus y and find that derivative. So the derivative of 2x is 2 plus derivative of y is dy dx times e to the 2x plus y. And now what we're going to do here is we're going to distribute the numerators, or distribute this, so that way we can separate it from the dy dx. We're going to be left with negative 1 divided by the square root of 1 minus x minus 2y squared. So that's when we distribute this to the 1, and we're going to now do it to the minus 2 dy dx. So we're going to be left with plus 2. Remember, negative 1 times negative 2 is 2 times the square root, times the square root of 1 minus x minus 2y quantity squared times dy dx equals, and I'm going to distribute this side too, 2 e to the 2x plus y plus e to the 2x plus y dy dx. Now we're going to move all the dy dx's to the left side and all of the constants to the right. So I'm going to do this in one swoop. If you need me to explain this later, I will be more than happy to. But we are left with 2 divided by the square root of 1 minus x minus 2y quantity squared minus e to the 2x plus y dy dx equals 2e to the 2x plus y plus 1 divided by the square root of 1 minus x minus 2y quantity squared. And finally, we are going to divide this stuff to both sides, and we're going to be left with the following answer. So what I'm doing here is I divided this part with the dy dx to both sides. It'll obviously cancel out, and we are left with dy dx is equal to the following fraction. So that's how we take these derivatives. We'll do a couple more quick problems. This time they want us to write the equation of a line tangent to the curve below at negative 3, 4. So this should be a pretty basic problem. Just a quick review before I give you the really spicy one. So we take the derivative of each. So the derivative of x squared is 2x plus 2y dy dx equals 0. Solving for dy dx, we get dy dx is equal to negative 2x divided by 2y, which is just equal to negative x divided by y. When we substitute in the negative 3 and negative 4 into the problem, we get negative 3 divided by 4, which is just 3/4. So the derivative here, or the slope of the tangent here, is 3/4. Now they want us to write an equation of a line. So from here, what we're going to do is start with a point slope formula. We have y minus y sub 1 equals m times x minus x sub 1. They wanted us to find the equation of a tangent at negative 3, 4. So y minus 4 equals m, which is 3/4, times x minus negative 3. We get y minus 4 equals 3/4 x plus 9/4. Actually, we're going to leave it at this, x plus 3. Remember that we didn't have to solve it all the way. We left it in point slope form. We're done. So what we're going to have you do next is this spicier problem, which is to write the equation of a line normal to the curve at 2, 7. So again, need to find the slope. So that's what we're going to do first. Remember, the derivative of 2 to the x becomes 2 to the x times ln of 2, or ln of x. Sorry, I meant ln of 2 minus minus 3. Remember, x times y is product rule, so derivative of the first, which is 1, times the second, plus derivative of the second, times the first, plus derivative of log base 7 of y becomes 1 divided by y ln of 7 dy dx equals 0. So now we're going to put the dy dx's together, and we're going to move the non-dy dx's to the opposite side. We are left with negative 3x plus 1 divided by y ln of 7 dy dx equal to 3y minus 2 to the x power ln of 2. We are going to now divide to get our dy dx by itself. We're going to be left with dy dx equals, notice all I'm doing is I'm copying and pasting at this point, that original numerator divided by this denominator. And now we're going to substitute x and y in there. Now we get 3 times 7 minus 2 to the second power, ln of 2, divided by negative 3 times 2, plus 1 divided by 7, ln of 7. And that's going to give us our answer for the slope. I'm going to pause this really quick so I can give you an exact number. So your answer in this particular case turns out to be dy dx equals negative 3.076. And so that's the slope of the tangent. Remember, we want the equation for the normal. So we're going to start with our point slope formula. Y minus y sub 1 equals m times quantity x minus x sub 1. So y minus 7 equals 1 divided by 3.076 times the quantity x minus 2. So a couple things to notice on our slope of the tangent, or slope of the normal. First things first, it was originally a negative here, as you can see. Because we had to do the negative reciprocal, we changed the sign back to positive and we put it under the 1, so it became 1 divided by, so that was our reciprocal. So that's all for now. We're going to eventually work on this problem in class as a warm-up. So if you want, you can take a look at it. If not, we'll do it in class. But that's all for now. I'll see you guys next time.